In this video, we're going to be looking at the mean and the median and talk about when to use one or the other. The mean and the median are both measures of central tendency. So basically they're used to compute the average of a set of data. So let's look at how to compute each. Consider the numbers from 1 to 5. So 1, 2, 3, 4, 5. The mean is the one you're probably familiar with, simply adding up the values and dividing by the total number of values. So if you're, for example, when you're finding your test average in your class, you add up your test grades and then divide by the number and you get your test average and so forth. So in this case, if I add the numbers 1 through 5, I get 15. There's 5 values, so I divide by 5, I get 3. That's how you compute the mean. Now the median is the middle value of the distribution. So in order to compute it, you want your data to be in either ascending or descending order, and you simply take the middle value. If you have an odd number of values, there's always going to be a middle one. Now if you have an even number, then you take the middle 2 and divide by 2. So if this had a 6 here, I would add the 3 and the 4, divide by 2, and I get 3.5. So the mean in that case would be, the median in that case would be 3.5. So if the distribution is evenly distributed or spaced, the value of the mean and the value of the median are going to be pretty close together. The mean has a lot of statistical significance because it's using a lot of formulas, standard deviation, the variance, and so forth. Now, if you compute these on a computer program or a calculator, you won't see that. But if you manually compute, say, the standard deviation, one of the first things you want to do is compute the mean for the set of data you're looking at. The problem with the mean, though, is that it's affected by extreme values. So if you have a lot of high values, large values, or a lot of small values, it's going to affect the value, or it doesn't affect the value of the median. Okay, so in other words, if you have a distribution that's skewed one way or the other, either to the right or to the left, then a good thing to do if you want an accurate representation of the mean or the average of the distribution is to use the median. Let's look at an example of what I'm talking about. Let's suppose we consider the following. So we have the salaries for the starting lineup of an NBA team, and I just made these up. So let's say these are the starting 5, and one makes 100,000. One player makes 100,000 a year, one 450, the other 800,000, and then the next one 1,250,000, and then the superstar of the team makes 8 million. Well, if we add these up on a calculator and divide by the total number of salaries here, which is 5, you're going to get a mean of 2,120,000. Now, I do have these in ascending order, so you want them in order of size, either from smallest to largest or largest to smallest. And then if you do have an odd number of values, it will be a middle value. In this case, you can see that 800,000 is the middle value. So that's what we call the median. So in this case, the mean is 2,120,000 and the median is 800,000. Well, if you're looking at this, which one is more representative of the average? And the answer should be the median. Because notice the majority of these players make less than 1 million. So none of them make close to the mean of 2,120,000. So a better average for this distribution is found by using the median, which is 800,000. Okay, so again, if you have a distribution that's skewed, okay, you have a lot of large values or a lot of small values one way or the other, and you want an accurate representation of the average for that distribution, then your best bet will be to select the median. Okay. So that concludes this short video, and we'll follow up with some other videos later on. If you have any suggestions, again, as usual, please post them and let me know your ideas. And again, I do appreciate if you subscribe to my channel. We'll see you in the next video.